When you're simplifying radicals, that means break it down as far as it can go. We want to make sure that we remember all of our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. The reason I say pay attention to what your perfect squares are is that is going to have you take out perfect squares, and it will cause you to make your tree, that your prime factorization, a lot less work. So if we take 80, you want to find your biggest perfect square that it goes into. So find in your list the two numbers that 80 is in between. It's between 64 and 81. In your calculator, start doing 80 divided by 64. See if it works. 80 divided by 49, divided by 36, 25. You'll notice that 80 is 16 times 5. And you need to remember that you are still taking the square root of both of those numbers. That did not change. When we separate this, because one big square root is the same thing as two square roots, it is still the square root of 16 times the square root of 5. Well, the square root of 16 is 4, and the square root of 5 does not break down any further, so that would simplify into 4 square roots of 5. When I'm working over here with a negative, whenever you are taking the square root of a negative, we have an I in your answer. So I'm going to take out that square root of -1. So I have that I in my answer. And I'm going to go ahead and start working with 150. And I'm going to see how that breaks down. 150 is larger than 144, but I do know that 144 does not go into it nicely. Neither does 100 or 121. But let's go ahead and let's try 81. You'll notice that 81 does not go into it nicely. Neither does 64 or 49 or 36. So what we have is we have 25 times 6. 25 is your perfect square. 6 is your not perfect square. So we're going to keep separating these out. This gets me the square root of 25 times the square root of 6. Well, the square root of 25 is 5. And all of these things are still being multiplied together. But the proper way of writing this is not with the I first. So we're going to flip-flop that around. 6 cannot get broken down any further with any perfect squares. So we would leave this as 5I square root 6. Looking at another problem where we have to add some things together, we want to work with these individually. I notice that I have a negative inside that square root, so I'm going to pull out that I, and I have 225 left, and actually 225 is a perfect square. That is 15. I'm adding on there 2. I see that negative, so there's an I in there. And I have the square root of 64. Well, the square root of 64 is 8. So all of those things are being multiplied together, which is going to simplify that part to be 16I. So my problem comes out to be 15I plus 16I, which in the end is 31I. Again, the easiest way to work with these simplifying radicals is write your perfect squares down the side of your paper and start dividing by your perfect squares. That will save you from doing your big long prime factorization tree and looking for groups of 2.